Okay, so we're looking at topic 3.5, initial value problems, question 3a. So the gradients of several lines are given in the functions below. When they say gradients, they mean slope, and by slope, they mean the derivative. So they're telling us, they're giving us the derivative. Points in the lines are also given, okay? These are the values that we're able to sub in afterwards. Use this information to first recover the function. That means undo the derivative, and you undo a derivative by integrating it. Secondly, find the area under the curve for the stipulated range. We'll talk about that in a second. So let's start with our derivative. The first one's a pretty interesting derivative here, actually. So it's dy dx. Now they have dy x dx. Same thing, y of x basically here stands for the function. So they're saying the derivative of the function with respect to x. It's written a little differently, but it's the exact same thing for us, okay? So dy dx is equal to 6x squared plus 10x minus 10. Oops, it is, yeah, I put in a bracket there by accident. Minus 10 times the natural log of x. Okay, and then they've got a plus 2x cubed plus 5x squared minus 10x minus 7 all over x. Okay, so briefly before I go into how to do it, the first thing that would pop into someone's head here is that, the derivative of this thing is this thing here. So I could swap them out and have u's, and that's fine to a point, except you run into a dead end. You end up letting this being u, but here I still have my log of x. And it'll be du, and that's no good to me for integrating, because while I can integrate u with my du, I can't do it for my x. So that initial first thing would throw you off. So I'm just going to explain the methodology for doing this. So first, if I want to derive it, I've got to bring my dx over. So I have 6x squared plus 10x minus 10 times the log of x plus 2x cubed plus 5x squared minus 10x minus 7 all over x, and of course I've got my dx now on this side. And what I want to do to recover my function is I want to get rid of my dy's. I want y's in terms of x's, so I integrate both sides. Now let's just talk about integrating. Integrating the left is easy. That's y is equal to. Now if I was integrating the following, for example, integrate x squared plus 3x. Now I would first integrate the x squared, x cubed over 3, then I'd integrate the 3x squared over 2. So all I'm saying is we integrate when you're adding or subtracting here, you're integrating them separately. It's the same as integrating x squared plus the integral of 3x. So the integral of x squared is going to be x cubed over 3, and 3x is going to be 3x squared over 2. So you're actually integrating them separate. So when you have things that are adding or subtracting, you can write them as separate integrals, and we're just going to use that there now for a second. So I'm going to focus on the this integral for the moment. Okay, so I've got, so what I meant is I'm integrating them separately, so I'm integrating both pieces. So I'm going to focus on the right-hand integral for the moment. 2x cubed plus 5x squared minus 10x minus 7 all over x dx, and I want to integrate that. Okay, so I definitely can't do substitution here, because if I differentiate the top line, it's not going to look like the bottom, and if I differentiate the bottom, it's not going to look like the top. So definitely not substitution. So let's try parts. I'm going to let u equals to 2x cubed plus 5x squared minus 10x minus 7. So when I differentiate that, I get 6x squared plus 10x minus 10, and I bring my dx across, so it's all dx. Yeah, perfect. Okay, now my other side, so my dv is going to be 1 over x, so I'm going to integrate both sides of that, and I'll end up with v is equal to the natural log of x, and those are my important pieces there. Okay, so if I'm looking for the integral of this here, I use my formula of the integral of v du is equal to uv minus the integral of, apologies, and I wrote that wrong, I keep doing that. The integral of u dv is equal to uv minus the integral of v du. Okay, and you can slow this video down if I'm going a little bit fast for you. Just go into the cog section on YouTube and change your playback speed. So they're looking for the integral of 2x cubed plus 5x squared minus, oopsie daisy, pen stopped working, minus 10x minus 7 all over x equals to uv. So in our case, uv is the following: 2x cubed plus 5x squared minus 10x minus 7 all over, apologies, not all over, what am I saying, multiplied by the natural log of x. And then I am minusing the integral of v du, which is 6x squared plus 10x minus 10 and log of x, natural log of x, dx. Okay, so we have this little beast done here. We've got our derivative of the second section of this part here. So I'm going to utilize that. I'm going to bring it over to where I was at the start. So here I am trying to do my integral. So the first part, I'm not going to do anything with that yet. I've got 6x squared plus 10x minus 10 times the natural log of x plus the integral of this. Now, I just figured out the integral of that a second ago. I have it down here. It's all of this guy here. I might kidnap him, actually. Let me see if I can do that. Lasso it. 2 seconds. Brilliant. I was able to lasso that in there. Okay. So, so I show a dx there, of course. So what I've got is my integral of 6x squared plus 10x minus 10 times the natural log of dx. And then over here, I have minus the exact same thing. So I have the integral, and I have minus the same thing. So that means 1 minus 1 is 0. So that means they cancel each other out. And that leaves me with 2x cubed plus 5x squared minus 10x minus 7 times the natural log of x. Okay, so finish my integral plus c. I don't want a c, so I'm going to use the value they gave me. They're saying y of 1 is equal to 4. What they're saying, now normally I see an expression y of x or f of x, so what they're saying is that is the x value, and when I put in that value for x, it gives me this y value. So when x is 1, y is 4. So I'm going to pop that in there. So when x is 1, y is 4. So 4 equals 2 times 1 to be cubed plus 5 times 1 to be squared minus 2 times 1 minus 7 times the log of 1 plus c. All right. So I put that all into my calculator there. And I'm going to end up with, well, it doesn't really matter what I end up with, because when you get the log of 1 here, that'll turn to 0. So let's just, I suppose we'll complete it out. So what's that? 2 and 5 is 7 minus 10 minus 3 minus 10. So I've got minus 10 multiplied by the natural log of 1 is 0 plus c. So obviously minus 10 by 0 is 0. Leave me with c is equal to 4. So to recover my expression, I have my derivative, but now I know my c. So my recovery is y equals 2x cubed plus 5x squared minus 10x minus 7 times the natural log of x plus c, but c is 4, so plus 4. Okay, I'm going to pause it there now and just go back to address the next part of that question.